The question in this video is, does a 80 volt transformer, AC transformer, made for say 110 volts to 130 volts, 50 Hertz, or say 60 Hertz, does it give out really 18 volts? And say the answer is that such a indication is a nominal voltage. And I found that out many ways in the past during the 30 years that I was busy with electronics. And of course it's not only theory but it's practice, and I need it of course for my square wave oscillator, of which I have talked earlier in an earlier video. A higher voltage than say common, and with common I mean that such a square wave oscillator often is able to push out voltages in the order of 9 volts peak peak or 10 volts peak peak. But I want to make a circuit with a higher output voltage. Anyway, will that be successful? I don't know. Anyway, no problems with that. This is the transformer that I'm going to use. It is nominal 18 volts, but is it really 18 volts? So the first idea of course is test the open voltage without any load on the secondary that has to say supply your electronic circuit. In this case, this one. What is the open voltage for this transformer? Nominal for 18 volts. It is 22 volts. Is that shocking? Of course not, because every transformer has a AC transformer has a nominal output given a certain current, and at the moment there is no current flowing out of the secondary winding to the meter here. So this is the pure open voltage, and this is again the schematic. Pure open voltage. Well, important to tell is of course that this open voltage is something to account with, especially when you want to use such a transformer in a bridge rectifying circuit, and that's here. Here is a bridge rectifier. When you have here, say this is the voltage that is told that it has, but in reality it's 22 volts. That means that at the output of the bridge rectifier is the voltage, the open voltage here, not 18 volts but 22 volts multiplied by 1.4. That means that we have here out 31 volts. that means that you need a smoothing capacitor that can handle that voltage. And the safe value is always 20% higher. So when you have here 18 AC volts out, the open voltage after the bridge rectifier is 31 volts, or 35, or perhaps even 38 volts, and then we are in the 40 volt range. Anyway, that's important. But of course, when there is here a load, could be whatever, an amplifier, another resistor, a resistor with, say, different values. That means when there is a circuit here with a resistive action, could be that the voltage changes constantly here when more or less current is taken by that electronic device. That's the reason why we use in good cases, special cases, not always, a stabilized voltage supply that can handle that issue. Anyway, well, again, the schematic, not so much more to tell. So let's see what happens when we connect here a load. And I've used this purely resistive load that is an automotive lamp. And let's see what happens when we connect that to the AC output, not via a rectifier or so, but purely to the AC output that's here. So between these two contacts, and when we connect it, you see the lamp light up. Of course, completely logical. The lamp takes up current. Ohm's law is valid in this case, and you can see that the voltage drops to 9.2 volts. So the transformer was nominal for 18 volts. The open voltage is 22 volts. The voltage under a quite severe load is 9 volts. And well, talking again about the bridge rectifier, you have of course to take into account open voltage. That's very, very important. Otherwise, and also regarding the smoothing capacitor, the maximum voltage that it can handle. Otherwise it doesn't go good. So open voltage, bridge rectifier 1.4 times the AC voltage, and use the good quality maximum voltage smoothing capacitor. Not maximum, but anyway, take that amplification factor into account. So, when you want to do more experiments, of course you can say, search for a load here. This is a heavy load, but you can search for a resistive load that makes that the transformer exactly gives out 18 volts AC. That's a good idea. Then you know what the transformer can bring, etc., etc. When the load on such a transformer is too heavy, the core gets far too hot on the longer term or on the short term. It will burn out. Sometimes there is a temperature fuse inside such a transformer, not in this one, by the way, this is an old school one, that luckily does not have such a temperature fuse, so you have to decide for yourself and say align the output current to the proper value anyway, well, that was more or less a good idea. And well, anyway, let's disconnect that heavy load, that 12 volt automotive lamp, and see what happens. The voltage goes up again to 22 volts. Completely logical. Ohm's law is valid. Show the schematic again. And say there was not so much more to tell. Of course, you can connect here an ampere meter to see the maximum current, etc., etc.